Okay, in this video, let's solve for the indefinite integral or the antiderivative of the cotangent of x with respect to x. Okay, so this integral is not as straightforward as simply finding the antiderivative of sine of x or the cosine of x. We know that these two are related to each other. In the case of the cotangent of x, well, we know that the tan of x is the ratio of sine to cosine, or simply sine over cos, sine of x over cos of x. The cotangent of x is the opposite, or is the reciprocal. It's the ratio of the cosine of x over the sine of x, or simply cosine of x divided by sine of x. So effectively we are integrating the division of the cosine of x on the sine of x dx. I can think of two ways of approaching this, and we'll go through both of them. The first one is to use the f prime of x on f of x principle. You may have learned that the integral of this type is equal to the natural log of the f of x, the natural log of the function of interest, plus a constant. The second method we'll use is substitution. It's just a simple substitution, and we call this a u-substitution. So let's go ahead and do method number one first. Okay, so for method number one, what do we realize about the cosine of x? Because if we let the function f of x equal the sine of x, or the derivative of the function f prime of x is equal to cosine of x, is it not? Sine differentiates the cosine. So by realizing this, we simply put the integral into the form of f prime of x over f of x dx, which equals, as we said, was the log of the absolute value of f of x plus c. And of course, in our case, f of x was equal to the sine of x. So therefore, the integral of the cotangent of x is equal to the log of the sine of x plus c by method number one. Let's see if we get the same result with method number two. And by the way, method number two really is closely related to method number one. So to make the substitution, let's let u equal sine of x. Then the derivative du dx is equal to the cosine of x. And I can separate the differentials and make du equal the cosine of x by dx, and thus the expression of the integral of the cotangent of x dx, which equals the integral of the cosine of x on the sine of x dx, is equal to the integral of, so this component here, cos x dx, is equal to du, let's write that down, over this component is u. So integrals of this form also evaluate to the log of the absolute value of u plus c. So now we simply back substitute u for sine of x. So the integral of the cotangent of x dx is equal to the log of the absolute value of sine of x plus c. And this is method number two. And we see that we get exactly the same result as method number one. So that's two ways of finding the antiderivative or the indefinite integral of the cotangent of x. That will do it for this video. If you have found it useful, please like, please share it with your study mates, and please subscribe to my channel for more videos that may help you with your math studies. Let me know what videos you would like me to do by commenting below. Thank you for watching. Best of luck with your studies, and I'll see you in the next video.